Now we're going to do a slightly more complex redox reaction example. We're going to be dissolving magnesium again, and this time we're going to be dissolving it in a solution of gold 3 nitrate. When the magnesium dissolves, a shiny pure gold precipitate forms. So we will start by writing our balanced redox reaction. We're going to start with solid magnesium. And it's going to be dissolving in a solution of gold 3 nitrate. So the symbol for gold is AU, and nitrate, of course, is NO3. Our gold is gold 3, so that means gold is a +3. Nitrate, of course, is a +1. So there needs to be 3 nitrates to balance out each gold ion. The result of this reaction is that we'll form magnesium nitrate. Magnesium forms a +2 ion. Nitrate being the -1, there needs to be 2 to balance it out, and we will have some solid gold. All nitrates are soluble, so this is aqueous. Magnesium nitrate will also be aqueous, and our precipitate is a solid. Now we can go about balancing this reaction. We see that there are 3 nitrates in the reactants and 2 nitrates in the products. We need to make sure that we have an even number of nitrates on both sides, so we're going to double the gold nitrate, and we will put, which gives us a total of 6 nitrates, so that means that we need to have 3 magnesium nitrates. We'll also need a 3 in front of the magnesium and a 2 to balance out the gold. So our balanced redox reaction is 3 magnesiums plus 2 gold 3 nitrates gives us 3 magnesium nitrates and 2 gold atoms. Because we have magnesium metal becoming magnesium ions and gold ions becoming gold metal, we have a transfer of electrons. Therefore, we can write half reactions for this redox reaction. The first half reaction that we're going to write will start with magnesium. Our solid magnesium is transformed into magnesium ions. Those magnesium ions have a 2+ charge because magnesium is a group 2 metal and it forms 2+ ions. They are, of course, in aqueous solution. And we have our mass balance for our half reaction. A magnesium atom becomes a magnesium ion. Now we need to do our charge balance so that we account for the fact that we have made a 2+ ion. This means that the magnesium metal loses 2 electrons in order to become a magnesium ion. Because electrons are a product, magnesium metal is losing electrons. This is our oxidation half reaction. The other half reaction involves the gold. In the reactants, the gold is found in the form of gold 3 nitrate, which means that the gold is Au3+. It's in an aqueous solution, and through the reaction it is transformed into solid gold, which is just Au solid. In order for this ion to become this atom, the charge has to be balanced. We have 3+ charge in the reactants and no charge in the products. That means that the gold 3+ ion is going to gain 3 electrons. Therefore, the overall charge on the reactant side is 0, and the overall charge on the product side is 0. Gold has gained electrons, the gold ion has gained electrons to become gold atom. Therefore, electrons are a reactant. The gold 3 plus is gaining electrons, so this is the reduction half reaction. The only thing that we have left to do is to look at the reaction stoichiometry and make sure that we have the proper number of magnesium atoms becoming magnesium ions, the proper number of gold ions becoming gold atoms, and the proper number of electrons. So we simply look up at the stoichiometry of the reaction. We see that there's 3 magnesiums, so we need to multiply the entire oxidation half reaction by 3. So the complete oxidation half reaction will be 3 magnesium becomes 3 magnesium 2 plus 6 electrons. The gold half reaction, well, there's a 2 in front of the gold nitrate, so that means we will multiply the entire gold half reaction by 2. So we'll have 2 gold ions. We will have the 2 gold ions in total will gain 6 electrons, and they will form 2 gold atoms. And that is the reduction half reaction.